Video. We are going to solve find the closest number. In this question, we are given an array of length n along with the value k, and we have to return the array element which is closest to the given value k. And if array elements having same difference with the given value k, then the number with greater face value will be our answer. See with example 1, there are four elements 1, 3, 6, and 7. Value of k is 4. The difference between 1 and 4 is 3, 3 and 4 is 1, 6 and 4 is 2, and 7 and 4 is 3. So as we can see, 3 is the closest number with difference 1 to 4. Hence our answer is 4. And there is only one candidate. In example 2, you are given an array with 7 elements and the value of k is 4. However, there are two elements, 3 and 5, with similar distance. 3 difference between 3 and 4 is 1, and 5 and 4 is also 1. But however, I told you earlier that if there are two elements with same difference, then the element with greater face value, which is 5 over here, will be our answer. Also, if you look at the complexity given, it is expecting us to solve this question in log of n, which means we have to solve this question using binary search method. So first of all, I will start with declaring two variables, low and high. Okay, low and high, low with 0 and high with n minus 1, and result with minus 1. Result equals to minus 1. This is what we will compare. Okay, because difference can only be positive. Okay, we will calculate the absolute difference. So while low is less than equal to high, which means while we are within the bounds, we will calculate first of all the middle value, which is low plus high minus low by 2. Okay, now first condition, base condition, if this middle value is our candidate, then we will return k. If this middle value is itself our answer, we will return the value k itself. But if this middle value is less than equal to k, if this middle value is less than or equal to k, then we will check we will check if this result is still equal to minus 1, which we initialize it with. Okay, which means that no closest element has been found yet, or if the current middle element, just the array of m, is closer to k, then the current result will also get updated. Which means if this result is still minus 1, which means no closest element have been found yet, or this middle having less less difference value. Okay, middle having less difference value, then we'll update the value of res to array of middle. And since we are already in the left side, on the leftward side, so we'll move left low value to the right side of the middle. Now the next condition, we will check if the middle if array of mid is now greater than or equal to k. If array of middle is greater than or equal to k, or we can simply apply else over here rather than applying another mid. So if array of mid is greater than k, cool. Now we will check if result is still minus 1, which means no closest element has been found yet. Or we will check if the array of mid is closer to k than the result. If that is the case, we will update the result to array of m. How? So again, similar thing. If result minus k is more than or greater than or equal to absolute difference between array of m minus k. If that is the case, we'll update the result to array of m, and we'll move towards the left side. And after that, we'll return our result. we will return our result. So by this time, either result will still be -1 if we have not found any closest element, or it will get changed since we have found it. So as you can see, it does pretty amazingly in very less time. Okay, so I hope you learned a beautiful concept, an amazing question, and enjoyed this video. Thank you. Have a nice day.